Assalamu alaikum. Today I will present this study titled Bulb and Internal Response to Selective Caries Excavation by Ricucci et al. It was published in Journal of Dentistry in the 21st of May 2020. The idea of leaving caries dentine on top of bulb dated back to Pierre Fauchard. The rationale behind that was to protect the bulb from being exposed, which was explained further by Massler, who made the distinction between the active and arrested carious lesion. Byers et al. Observed that sclerotic tertiary dentine is impermeable to relatively large nanoparticle, and that the tertiary dentine form an effective barrier against the penetration of toxic material into bulb organism, which left an affected dentine are entrapped within a stressful environment where no nutrient derived from the oral environment supplied to these organisms. The International Caries Collaboration to 2015 advocated that complex excavation of carious tissue to hard dentine is over-treatment, and they favored selective stepwise removal of carious tissue. For that, the presented study strived to investigate the histobacteriological condition of a human carious dentine and the histological response of dental bulb after selective carious excavation to form dentine and cavity restoration with adhesive procedure. The hypothesis tested was that selective excavation arrests carious progression and prevent infection of dental bulb without creating adverse bulbal reaction. For the method, the present study included 12 carious third molar teeth from 12 human subjects. The mean age 35 years. 4 intact third molar were used as the control. The teeth were scheduled to be extracted for a prosthetic or orthodontic reason. Selection criteria: presence of an exclusive occlusal caries lesion with intact interproximal surface, caries lesion infiltrating half or 2/3 of the occlusal gingival dentine thickness, absence of spontaneous pain in the dental history. The tooth was asymptomatic and diagnosed as reversible bulbitis. Periodontal probing depth not exceeding 5 mm, and the tooth could be isolated with rubber dam. For clinical procedure, the enamel cavitation was enlarged with high-speed cylindrical diamond burr with water spray, and they used stainless steel round burr with low-speed hand pieces with water cooling, and selective caries excavation was achieved using sharp hand excavator until firm dentine was encountered. After caries excavation, each cavity was restored with composite restoration, and the restoration were finished and polished. Then they took a radiograph during all phases of restorative procedure, and the patient were instructed to report post-operative sensitivity or discomfort. The teeth were extracted after observation period, ranging from 1 to 9 months. Thermal and electric bulb tests were performed prior to extraction. Periapical radiograph and intraoral photograph of occlusal surface were also taken before extraction. The teeth were extracted as atraumatically as possible, and immediately after extraction, each tooth was gently washed to remove blood and saliva, and they immersed in 10% neutral buffered formalin. Now for histological criteria, Each tooth was sectioned 3 millimeter below cement to enamel junction, demineralized, and the specimen were rinsed in running tap water for 24-hour dehydrated using ascending grade of ethanol. The serial section was performed 5 micrometer thick, H&E for evaluation of bulbal changes, and the Brown and the Brent technique for bacterial identification. The slides were examined using a light microscope for acquisition of digital photograph. The histologic criteria were presence and absence of irregular tertiary dentine, reduction in odontoblastic layer, presence of stainable bacteria in the dentine, overlying the bulb, capillaries filled with the blood in odontoblastic and subodontoplastic layer underneath the cavity, which indicating hybremia, the presence of acute neutrophilic leukocytes or chronic inflammatory cell as lymphocytes, macrophages, plasma cell, an increase of leukocytes in the blood vessel afferent to the bulb beneath the cavity, which indicative of chemotaxis. For result, no patient reported post-operative discomfort. All teeth examined in the present study were asymptomatic during the varying observation period and responded within normal limit to the thermal and electric bulb test immediately prior to local anesthesia for tooth extraction. The four control intact showed dental bulb with no changes, and the dentine predentine odontoblast complex, tertiary dentine in the experimental group. All 12 teeth show layer of tertiary dentine with varying thickness. An inflammatory cell were identified in the bulb connective tissue in all specimens. These appear as a scattered or accumulated capillary. In all specimen, capillaries were heavily filled with erythrocytes and the subodontoblastic lesion, leukocytes, and the vessel. Examination of a serial section revealed an increased number of BMN leukocytes and afferent bulbal vessels in all experiment specimens. Bacteria and dentine. A large amount of stainable bacteria was observed in the dentine subjacent to the cavity floor in all specimens. The dentinal tubule were heavily colonized by bacteria to a significant depth. High magnification image showed that the lateral branches of the dentinal tubule were also colonized. Now, bulb changes such as formation of tertiary dentine and reduction of odontoblast layer were present in all cases. These features are attributes primary to the carious process, the presence of an inflammatory cell, congested capillary in the subodontoblastic layer, and BMN leukocytes in the afferent vessel are indicative of unceasing irritation caused by the presence of noxious stimuli derived from bacteria that resided within the secondary tertiary dentine. Conclusion: the hypothesis that selective excavation arrest caries progression and prevent infection of the dental bulb without creating adverse bulbal reaction cannot be validated by the results of the present study. And thank you.